Let's take a look at our second example of solving a quadratic inequality. So we said the first thing we do is pretend it says equal to, and we solve using any of our regular solving methods. So for this particular problem, because I see parentheses squared and everything else is a number, I'm going to solve by square rooting. So to do that, I'm going to keep the 2, keep the x minus 1 squared. I'm going to move the 18 over, pretend it's an equal sign, okay? Then I'm going to divide out the 2 next to get that x minus 1 squared is equal to 9. And now I can square root both sides. So if I square root the left, that'll make the parentheses squared go away and leave me with x minus 1. If I square root the right, I'm square rooting a number, I need the positive, negative. So I have positive and negative 3 here because the square root of 9 is 3. And I can break this into 2 separate cases. One where I do the x minus 1 is equal to positive 3, and one where I do the x minus 1 is equal to negative 3. Add the 1 over to get x equals 4. Add the 1 over to get x equals negative 2. Okay? So those are the two x-intercepts. And then we can go through our 2 different methods. So let's take a look first and foremost at how could I do this if I were going to sketch a graph and shade, and then the alternative is to test points, all right? So I'm going to go with method 1 over here, which was sketch and shade. And in order to do that, I need to go back to the original inequality and replace the 0 with a y. So I'm going to really be looking at what is 2 parentheses x minus 1 squared minus 18 greater than or equal to a y, and then think about shading from there. When we do our sketch, we really just need the x-axis drawn. We don't need the y-axis. Our x values are 4 and negative 2. So negative 2 goes on the left, 4 goes on the right. There's an equal to in this inequality, so that means I have a solid line parabola going through this, so there's an equal to, so I can draw a filled in dot on each one. And then I need to just decide, does the parabola open up or does the parabola open down? And that's based off of this 2 right here. The a value is a positive, so that means the parabola opens up. So I'm just going to sketch a solid line parabola opening up through those 2 points. And then I need to consider shading. When you consider your shading, you're looking at this part right here. And read from the y. You have to decide, is y bigger than the parabola or is y smaller than the parabola? The point is facing the y, so y is smaller than the parabola. Smaller, that means go down. So here's my vertex. I would go down from here. So that's everything below, or in this case, outside. Okay, so I would be shading everything on the outside of this parabola. That means that from a number line perspective, I'm looking at this. I have negative 2, everything on the left of negative 2, and 4, everything on the right of 4. Okay, so I have 2 separate intervals to write here. All right, this side goes over to negative infinity, and then I end at negative 2. So I have negative infinity to negative 2. I can never equal an infinity, so that's a parenthesis. In this case, I can equal the negative 2, so that's a square bracket. Then I have my union symbol to join it with the other. The other one starts here at 4 and keeps going this way forever to infinity. So I start at 4 and continue on to infinity. I can include the 4 because there was an equal to, so there's a square bracket there. I cannot equal infinity, so that's a parenthesis. So that's my interval notation answer. Okay? But we said that we also need to be able to write these with inequalities. So if I look at this, I'm looking at negative 2. It's everything to the left of negative 2, so I have x is less than or equal to negative 2. It's 2 separate pieces, so then I have the word or. And then I have x. I have everything to the right of 4, so bigger than 4, so x is bigger than or equal to 4. Okay? So that's solving using method 1, the sketch and shade. All right, I'm going to make a separate video for those that would like to see the alternative method, which is the testing values.